So let's talk about matrices, since I kind of introduced them in the last section a little bit, but we need to talk a little bit and get some of the baseline stuff. A matrix is a rectangular array of numbers enclosed in the parentheses that can be used to represent a system of equations, which I did. Each number in the matrix is called an entry, and the size of the matrix is determined by first specifying the number of rows and then the columns. So the number of rows is 3, the number of columns is 2. The number of rows is 2, the number of columns is 3. So order matters, order definitely matters, and we will get to why in the next couple sections. So make sure it's always rows by columns when you're naming the number, the size of a matrix. Given that a system of linear equations, it is possible to represent either part of the system or the entire system using matrices. We can form a coefficient matrix, which uses only the coefficients of the variables, or the augmented matrix, which uses the coefficients and constant terms. So let's talk about this guy here. And we know that if we use the coefficient matrix, we would call this a 3, 2, -1, 5. And we would call this a 6, 0, -7. Notice there's no y term over here, so we put a 0 in that spot. And so that is our matrix. And we can call that augmented. And if I have a matrix, let's skip that. So if I wanted to solve a matrix like I did previously, I'm going to give you some time to play with this. And I'm going to write it as a matrix with just the coefficients, so 2, -3, 4, 14, 3, -2, 2, 12, 4, 5, -5, 16. And my first step that I'm going to use is I'm going to take 2 times row 2 minus 3 times row 1, and then I'm going to put it in row 2. Notice this is the first time that I've multiplied both of them by something, and I did that because there is no common multiple between 2 and 3, and this way I don't end up with a whole bunch of fractions. So I'm going to pause here at this point and do the rest of this problem while you're working on it also. So let's talk our way through this. I got it done now. So the first thing I did was take 2 times row 2 minus row 3 and put it into row 2, which gave me a 0 in that position. And then I took a row 3 minus 2 row 1, and I got that as 0 in that position. And then I did this 5 times row 3 minus 11 times row 2 and put it in for row 3 to get a 0 in that position. And if you notice, I get a 23z equals 138, which gives me a z of 6. So once I get, again, the zeros in that front triangle, I can just use regular algebra to solve the rest of it. So I get 5y minus 8 times z equals -18, which 5y, I'm going to add 48 to both sides. I get 5y equals 30, y equals 6. And then my last equation, I get 2x plus -3 times 6 plus 4 times 6, z is 6 also, equals 14, and I get minus 18 plus 24 equals 14. And it looks like I get minus 6 from both sides. Gives me 2x equals 8, so my x is equal to 12. So writing that value as a point, I get 4, 6, 6. Yeah. So let's look at the size of some of these matrices. This one is a 2 by 2. This one has 2 rows, 3 columns. So 2 rows by 3 columns. And this one is, of course, 2 by 2 again, and this one is 3 by 2. To be able to do matrices operations, we know that we're going to have the same size. We're going to be able to add those together, subtract them together. And to do that, we can do some operations. Let's show you those, and then we'll get to matrix multiplication, where we have to have another thing be true. But let's just do addition and subtraction. When we do addition and subtraction of matrices, we just add the components together. So my a plus c, I'm going to add 2 and negative 2, which gives me 0. Negative 1 and 1 gives me 0. 3 and 3 gives me 6. And negative 3 and negative 3 gives me negative 6. So by adding them together, I get that. And if I subtract a minus b, notice that a is a 2 by 2 and b is a 2 by 3. So we don't have enough elements in a to be able to. So we're going to just say we can't do that operation. Now, a scalar multiplication means that we are going to, just like we did with vectors, that means we're just going to multiply all of the elements by 3. So if I take my A matrice and multiply it by 3, I'm going to get a 6, negative 3, 9, negative 9. And down here, we're going to talk about matrix multiplication. Order matters. To multiply two matrices, the number of columns of the first matrix must match the number of rows in the second matrix. After this checks out, multiply row elements of row 1 in the first matrix by the column elements in the second one, and add those products, and this is the result. Okay, so let's kind of boil that down a little bit. What it's saying there is, if the middle two numbers, this one and this one, so this is rows by columns, so if the columns number here matches the rows number there, then you're able to multiply it. Okay, so the middle two numbers have to be the same. And the resultant of that multiplication will be the outside times outside. So the middle two have to be the same. What we get out of it is the outside by outside. So if I'm going to take matrice A times matrice C, let me get that. Make some room here. And so if we're going to multiply A times C, we're going to take the first row, which is 2, negative 1, and we're going to multiply it by the first column, which is negative 2, 3. So to do that, I'm going to need more room. There we go. So if I do that, I get 2 times negative 2, which is negative 4, plus negative 1 times 3 is negative 3. So I get that first element would have to be negative 7. Then to get this element, we would take the first row times the second column, because the position of this element is row 1, column 2. So you're taking row 1 times column 2 to get it. So let's do that. I get 2 times 1 is 2. Negative 1 times negative 3 is 3. So for the second element, I get 5. Now this element down here is going to be row 2 times column 1. So I go 3 times negative 2 is negative 6. And then negative 3 times 3 is negative 9. So I get a negative 15 for that position. And the last row, row 2 times column 2, I get 3 plus 9 gives me 12. And so there is my A times C. Now, let's do the same thing doing C times A, doing the other order. So I'm going to write A over here, just because I want them in the correct order when I do the multiplication. So this is my A. So I'm going to take the first row times the first column, and I get negative 4 plus 3 is negative 1. First row times second column, I get negative 2 times negative 1 is 2. 1 times negative 3 is negative 3. So I get another negative 1. And second row times second column gives me 6 minus 9. And negative 3 and 9 gives me 6. And I notice that AC and CA are not the same answer. So matrix multiplication is not commutative. It is not commutative. Okay? All right, let's just for the fun of it do B times D. I'm going to pause and write the matrices down. So we're going to multiply B times D that I have written there now. And like I said above, this is 2 rows, 3 columns. This is 3 rows, 2 columns. So since those are the same, we're able to multiply. The answer that we get will be a 2 by 2. So if I take the first row times the first column, I get 3 plus 0 gives me 3. First row times second column gives me 1 plus 2 plus 0. Second row times first column gives me 6 plus 0 plus negative 8. And second row times second column gives me 2 minus 6 minus 4. And let's do the same thing for the other order. And I'm going to rewrite that because I want to do it in the right order. 1, negative 1, 0, 3, 2, 3, negative 4. Because order matters. In this case, because we're doing a 3 rows times 2 columns, and this one's 2 rows times 3 columns, what we're going, because the middle two are the same, we're going to end up with a 3 by 3 matrix when we do this. So let's get started. Hopefully I can finish. So if I take the first row times the first column, I get 3 plus 2 is 5. First row times second column, I get negative 3, and 3 is 0. First row times last gives me the negative 4. Second row times first column gives me 0 minus 4. Second row, second column, I get 0 times negative 1 is 0. Negative 2 times 3 is negative 6. And I get 8. I get 4, I get 2 minus, or negative 2 plus minus 3, or plus 3, and I get negative 4. So obviously a 2 by 2 and a 3 by 3 are not, so we know it is commutative property is not going on with matrices.